Okay, so there we're going to learn interpret and determine the rates of change for related quantities. Okay, so you already learned two applications. One is a normal gradient of function. Okay, you already learned. Let's recap. Okay, so you already learned the first one is the tangent for normal. Okay, the second one you already learned about maxima and minima problem. All right, so today we're going to learn the rate of change. The rate of change. So when you look at the word rate, that means is something to do with time. Okay, so then the last one will be approximate change. Approximate change. Okay, so all of these are quite simple if you know the basic of differentiation. Okay, so let's go through the notes. All right, so if two variables, if two variables x and y change with time, t and r related by the equation of y equals to ft, fx, then the rate of change, y equals to fx, right? Then the rate of change is dy dt, and dx dt can be related by dy dt equals to dy dx times dx dt. All right, so here y can be anything, can be maybe area, okay, can be area, volume, or length, length. Okay, length, usually the length is x. So area, volume usually is the bigger one. Then the x will be maybe the height, the length, the width, or something else. Okay, so if what's the meaning? If dy dt is greater than 0, it means that y is set to increase at the rate of time. So of course, greater than 0 then is set to be increased. If dx dt is less than 0, it means x is set to decrease at the rate of time. So therefore, if dy dt is less than 0, okay, less than 0, then it's decrease. Or dx dt is greater than 0, then it's increased at the rate of time. Okay, so this information, this formula you need to know. Remember, that is dy dt equals to dy dx times dx dt. This you have to remember. I think you can remember for life, dy dt equals to dy dx times dx dt. This is called chain rule. You see here, x and x actually, if you use mathematics, it will cancel out. But in differentiation, we don't cancel it out. But we know that dy dt equals to dy dx dt. So it's a chain rule, right? So let's look at the example. Okay. So given the function y equals to 2x minus 3 times x plus 1, find the rate of change of y when x equals to 2. If x is decreasing at the rate of 2 units per second, okay, decreasing. So decreasing, remember, decreasing, therefore is dx dt equals to negative 2. So we need to find what is dy dx. Okay, at what point? At x equal to 2, right? So meaning that we need to find the value of dy dx when x equals to 2. All right, so let's see how. So this one is basic of differentiation. So when you see a 2 bracket, don't straight away use a u and v, okay? Don't straight away you use your u and v. See whether you can expand it first, okay? So already told you already before, if you want to use product rule, UV, make sure there is a square here, right? Or here got square or cube or any power, right? Power greater than 1, then you use product rule. If not, don't use, because it's troublesome. Okay, so don't use product rule. Expand first. Okay. So how you know in exam whether you want to expand and use product rule? Okay, again, you look at whether the bracket or the what you call it, the algebraic expression is there's a power there or not. Okay, all right. So usually we do a lot of question, then we know the trend. So to see the pattern. So that's why a mathematics is very there's a we call it looking at the pattern. Mathematics. Sometimes we look at the pattern, then we know how to do. Okay. So we expand it. So 2x squared, right? Then 2 times x, 2x times 1 is 2x. Then minus 3x, so 2x minus 3x, okay? Minus 3x, so you get negative x, and negative 3 times 1, negative 3. So that's how you get the answer. Then you differentiate, okay? Differentiate 1 by 1, so you get 2 times 2, 4x. And then differentiate x, get that 1. Differentiate 3 is, this one will be 0. Okay, so you get dx, dy dx equal to 4x minus 1. So you already done the first part. Then we substitute x equal to 2 in, right? So x equal to 2 in, right? So you have f prime 2, right? Sorry, should be dy dx equals to 4 times 2 minus 1, okay? So you get 8 minus 1, you get 7. So this is equivalent. If I put, if I use fx equals to 2x minus 3 times x plus 1, then I will use this symbol f2 equals to 7, right? So it's equivalent, right? So then we apply this formula, dy dt equals to dy dx times dx dt. So we have dy dx already, that is 7. And then dx dt, we have it already, that is minus 2 because decreasing at the time. So therefore, we have dy dt equals to negative 14, or we accept as the rate of change of y is negative 14, decreasing by 14 unit per second, right? So unit per second, right? So this is how you explain this, okay? Decreasing by 40 unit per second, right? So this is how you interpret what is dy dt, okay? So function y lah, So a bit confusing here. So what is f prime 2? Suddenly is f prime 2 equals to 7. It's actually dy dx if we set y is fx. Right? So fx. So why you have 2 here? F prime x is actually 4x minus 1 equivalent. So why you have 2? When we substitute the x equals to 2 here, right? So x equal to 2. Here we want to do this, right? X equal to 2. Therefore, you have 7 here. That's why you put 2 here, right? Right? So you have to know. So okay. Okay, so I repeat. The first thing, when you read the question, first thing you find dx dt, and then dy dx, and when x is what? What's the value? So it's given or not in the question. Sometimes it's not given, All right, so then we can apply to the formula dy dt equals to dy dx times dx dt. So remember there are 3 steps, 1, 2, 3, okay? Then we go to this question, all right, see? All right, so now is the rate of change of y is at unit per second. Find the rate of change of x when x equal to 2, all right? So we have, now we have dy dt is at, all right? So you need to find dy dx as when x is 2. But now we want to find dx dt. Okay, so what is dx dt? Right, I don't know why suddenly like that. Huh? So this is dx dt. So we apply to the formula dy dx, sorry, dy dt time dy dx times dx dt. So we want to find this. Okay, so first step already done. Second step, we need to do differentiation. So y equals to square root 3x minus 4. So we change into power of half so that we can differentiate. So when you differentiate, we get 1 over 2, 1 over 2, and then 3 times 3x minus 4, the power of negative half. So how to get this from here? So I put, and then you have c half, right? And then you differentiate the bracket first. Therefore, 1 minus half, okay? Okay, sorry. Negative half minus 1, huh? And then you differentiate inside. So differentiate this, you get this. That's why you get this, huh? Right? So this expression. So you simplify. Okay, so here y suddenly equal 2. So I don't want to simplify. Okay, I just substitute straight away when x equals to 2. I'm doing this already. First step done. Then second step, I substitute in. All right. All right. So because our main aim is to find what's the value of dy dx. All right. So the main aim is find dy dx when x equal to 2. So we substitute in. Use your calculator, this part. So you will get 3 over 4 square root 2. All right, 3 over 4 square root 2, or you use your calculator, you get 3 over 4 square root 2. Then we can apply to dy dt equals to dy dx times dx dt. All right, so let me clear this off. All the pen. Okay, so dy dt. So what is dy dt? Is 8, so we substitute in. So n equals to 3 over 4 square root 2 times dx dt. So this one, simple maths. Okay. So what is dx dt? So dx dt is 4 times 8, 32 divided by 3, right? And then over square root 2. So you use your calculator. I think you should get 16 over 3 times square root 2. Okay. Let me check whether correct or not. Okay. So this here, 4 times 8 is 32 divided by 3 square root 2. And then we times square root 2, square root 2. So here, therefore, this one become 2. And then we simplify, we get 16. So 16 over 3, square root 2, right? So here to here, again, so 2 and 2 cancel out. You have 3 square root 2. Okay, sorry. Oh, cannot cancel out, sorry. So it's square root 2, and this one's 2. So we do times square root 2, square root 2. So you get 3, 2 times 2 become 4, and then square root 2. So you get this. Sorry about I thought this one is straight away C2, we cancel out. So be careful in the exam. This one, 2 and 2, we cannot cancel out because this is 2 to the power of negative half. Okay. So therefore, this is our answer. So it's positive, bigger than 0. That means it's increasing. So this one, the value later on you can find it if you want it to be in decimal, then you use a calculator. Okay. So this is the step. If I want to find dx dt or dy dt, I must find dy dx at what is the value of x. Okay. And then we apply to dy dt equals to dy dx times dx dt. So the process is the same. Okay, let's go to problem solving. Okay, the right. Okay, so mostly of the question is, if paper 2, there will be problem solving. Is paper 1 it will be as some sort like this. Okay, so after this session, then I will give you a question to do. All right, so as your not homework lah, to fulfill your 2 hours later on, 1 hour, okay, of tutorial. Okay, the diagram on the right shows an inverted cone with a base radius of 5 centimeter and the height is 12 centimeter with some water. So water leaks out from a small hole, the tip, okay, leak out, okay. So with 4 centimeter cube per second, okay. Find the rate of change of depth of the water in the cone when the height is 3 centimeter. Correct to 4 significant figures. Okay, so what we want to find here is the depth. So that's mean dH dt. What is dH dt? So, and then we given dV dt as -4. All right. So therefore, we want to relate V in terms of H. Okay, in terms of H. So what is H? So we use the formula of cone. Okay. All right. So V equals to 1/3 pi r square H. But we have r square here. There are 2 variables here. One is the radius. One is the height. So meaning that now we want to find the relationship between B and H. And with T, right? With related to 3T. Therefore, we need to find R in terms of H. So how to do that? So it's given that, all right, the cone is 5 radius, the radius is 5, and then the height is 12. So we need to find R in terms of H, okay? So by using the ratio, okay? So how to get this? Right, so this is, all right, so let me explain. So this is, if I put this out, I draw it as a triangle. So if you have, this is R, this is original, R and H. This is a whole cone, right? Cone. So we need to find out when there is the R here and the H here, what is the, what is the ratio? Okay, what is the relation? So R original is 5, okay? Here the original is 12. So we find the ratio. The ratio must be is the same lah, because R over H should be equals to 5/12, right? 5/12. You already learned this before, huh? 5. So it's because it is a similar triangle. Okay, so therefore R over H equals to 5/12. So you can use tangent theta. Tangent theta. Okay, tangent theta is opposite over adjacent, therefore 5/12. So it's equivalent to the smaller triangle here is R over H. Therefore, you have R over H equals to 5/12. And hence R equals to 5/12 H. So then you substitute in the original formula for volume. Therefore, you have, okay, so let me clear off this. So therefore, you have 1/3 pi r square become pi 5/12 h square, h times h. Therefore, you have 25/432 pi h cube. Okay, so let's make sure it's correct. Okay, so 1/3, right? 1/3 times 5/12 square. So you have 25/432 pi h cube. All right, therefore, now we need to find dv dx. Okay, sorry. Okay, so I forgot. Here we need to find dv dh when h is 3. When h is 3. So we do dv dh. So you get 3 times 432. 3 times 25/432, you get 25/144 pi h squared. Then you substitute the h in. H equal to 3 in. So you get 25/144 pi times 3 cube, 3 square. You get 25/16 pi. Okay, therefore, now I can find what is my dH dt. So I'm using dV dt equals to dV over dH times dH dt. Okay, dV dt. Okay, dV dt equals to dV dH times dH dt. We substitute the value in. All right, so dV dt is then this 5 over 16 pi. Sorry, 25. dV dt is -4, right? 4. And then 25 over 16 pi times dH dt. Okay, so what is dH dt? So dH dt is 0.8148. All right, so it's decreasing, huh? The rate of change, the depth of the water. So is the change of the rate of water is 0.8148. So it should be negative here, right? So because it's decreasing, right? So it's come out is like 4, right? So it's the height will be decreasing. Okay, so how to interpret is dH dt, the height, the original height is here. So it's asking you about the rate of change of depth of water. So it's become shallow, right? More shallow going down, okay, downward, right? So it's decreasing, huh? Okay. So it's dH dt equals to negative 0.8148, all right? So it's only the symbol, negative or positive. All right, so now we go to the second question. So before that, remember, read the question. Right, for this question, we want to find dH dt and dV dt is given. All right, so and then actually, I forgot this one step. We need to find dV dH when h equals to 3, right? H equal to 3. Okay, so next. Okay, a radius of a spherical balloon filled with A increases at, okay, this one increases. So, right, the radius of spherical balloon, a balloon, okay, is increasing, right? So the A increasing at the rate of 0.5 centimeter per second, the radius, okay? So find the rate of change of the volume when its radius is 4 centimeter, correct to 4 significant figures. Okay, now we have dr dt increasing 0.5. Then we need to find dv dt. So therefore we find dv dr when r is 4 centimeter. So you can see very clear, when r is 4 centimeter, we want to find the rate of change of volume. Therefore dv dr, r is 4, okay? Volume and radius, vr, okay? Then here also got a clue, dr dt, you find dv dt. So dv dr dt, dv dt, so it is automatically we want to find dv dr. So for this question is the rate of change of depth of water and the volume, right? So therefore it's dv dh when h equals to 3, okay? All right, so the volume, the balloon. So what's the formula for the volume of spherical balloon is 4 over 3 pi r cubed. So we differentiate. Okay, this one is given. So dv dr equals 4 pi r squared. So we substitute r as 4. Right? So you already discussed here the step. Then dv dr equals to then 64 pi. Okay, then dv dt. So we use this formula, dv dt equals to dv dr, dr dt. Okay, therefore dv dt is 64 pi times 0.5. So it's 32 pi. So it's 100.5 centimeter cube per second. Okay, because so 4 significant figures. Okay, so right, so maybe this is the step. Maybe some of you will confuse why you teacher give us dy dt and then dy dx and dx dt. Then suddenly it come out like this, okay? All right, so this one, it depends on the situation. I said already, V, the Y can be volume, area, okay? The X can be radius, the length, the height, okay? So it depends on the situation, okay? So this is a second example. All right, the third example, okay? This is, I don't know, this is a advanced maths, okay? So it's sometimes it's nothing to do with okay, later on we will explain this 30 feet. This is very confusing. Okay. All right. So let's see. A man who is 6 feet tall. So I'm using a US problem. Okay. But in UK, we will use meter. Huh? So when you see feet, anything with feet, then it's a US problem. Okay. So a man who is 6 feet tall away from is walking away from a lamppost at a rate of 5 feet per minute The lamppost is 20 feet tall. So here the person will cast a shadow on the ground in front of them. So this is the shadow lah. Okay, this is the shadow. So it will form a right angle triangle. What's the meaning here? All right. So how fast the shadow grow when the person is 30 feet from the lamppost? When there's 30 feet, so how fast the shadow growing? The shadow will grow here, right? Okay, so when it's 30 feet, so what should we do? All right, so we are looking at dy dt. All right, we want to find the shadow is dy dt. Okay, so okay, I don't know what happened to my pen again. Suddenly malfunction, cannot write properly. Okay, see whether it's okay already. So we want to find dy dt. Okay, so it's a bit chat again. Okay, want to find dy dt. And then what else? So we want to find dy dx. When x is 30 feet away, and then we are given dx dt is 5 feet. Okay, let's see how to do. So we need to find the relationship between y and x. So how to get? The same as ratio again. 6 over y equals to 20 over x plus y. Okay, so 20, okay, 20 is the height of the lamppost, equivalent to the distance the man from the lamppost x plus the shadow in front. So it's x plus y. So you will get 6x plus 6y equals to 20y. Then you have 14y equals to 6x. Therefore, y equals to 3 over 7x. So now we want to find dy dx when x equal to 30. So when you differentiate, you get 3 over 7. Therefore, 30 here, meaningless. Therefore, if I put 20 feet or 50 feet, it will not affect the dy dx here, because dy dx will get a constant here, 3 over 7. So this constant will depend on the height of the lamppost and the height of the human here. Okay, so no matter where you stand, all right, the shadow is growing constantly, okay, without affected by the where they stand from the lamppost. Okay, so now I want to find dy dt. So dy dt equals to dy dx over dy dx times dx dt. All right, so let me clear off everything. So dy dt, we know dy dt, we want to find dy dt, sorry. So we have dy dx and dx dt. Therefore, you have 35 over 7. So feet, right? So this is feet, 7 feet per second. So the shadow growing 35 over 7. That's 35 over 7 is, sorry, is 35 over 7. Sorry, 15 over 7. Huh? So it's 15 over 7, not 35. Huh? This one is 15. Okay, 15 over 7 feet. Okay. All right, so let me rectify a bit. Okay. On. Okay. Huh? Right. Okay. All right. So let's go to, sorry. So next we go to the second part of the question. All right. Now the question asks about the tip. The tip. Where is the tip? Okay. Where is the tip of the shadow? The tip of the shadow is here. So it's L actually. So the relationship now is L is x plus y. Huh? So therefore L equals to x plus 3 over 7x. How to get y here? Do you remember? From this one. Okay, y is 3 over 7x, right? So the tip, so is L equals to x plus y. So L equals to x plus 3 over 7x. Okay, so L equals to 10 over 7x. So we do, actually we want to find the LDT lah. So the tips here. So the meaning dLdt, right? So we need to find the relationship between dl dx when x is 30 feet away lah, 30. So dx dt is still the same, that is 5 feet. Okay, so we do differentiation of L with respect to x, we get 10 over 7. Therefore, dl dt equals to dl over dx times dx dt. So dl dt equals to 10 over 7 times 5. Okay, so we'll get 50 over 7, right? 50 over 7, right? So it grows at 7.142, 143, right? Feet per second. So of course it's longer, right? The tip is longer, so the tip will be here, right? It's growing further, right? The y, just now we have looking at the y here, right? So dy dt, yeah. So now it's looking at dl dt. Okay. So therefore, you can see here the 30 feet. How far it's the person stand from the lamppost is not. This is not the concern. The concern here is the effect is the height of the lamppost and the person height also. If let's say I'm 20 feet, the lamppost 20 feet, for me is 5.5 feet, then therefore the tips of my shadow will be less than this. And also the rate of my shadow moving is also less than this, less than 15 over 7. Okay, so this is the question that is one of the question in your exercise. So if I don't show this later on, you will be asking me also. So I explain this first so that I can understand. Okay, so this is a very advanced question. So now is another advanced question. All right, a 15-foot ladder, again US question, is resting against the wall and the bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1 over 4 1/4 feet per second. How fast is the top of the ladder is moving up the wall? All right, so the ladder, okay, so like that, okay. So this is the ladder. So this is the ladder. So when you push the ladder in, so it will ask you what is what's the red, the I mean the top of the ladder here moving upward. So of course, when you push this, the ladder automatically will go up, right? So you go up like this. Okay. So the question asks you what is dy dt lah here, dy dt. Okay. So meaning that we want to find dy dt. All right. So this is another question. So we want to find dy dt. Okay. So equals to dy dx times dx dt. So dx dt is this going in. So going in will be negative lah, right? Negative value. So negative 1/4. So going, okay. If going this direction is negative, going this direction is positive, going up is positive, going down is negative. Right? Related to the y lah. Y is less, right? So therefore negative is going down, right? So some of the question can ask you if the ladder going down. So what is the red? The top, the tip of the X, the ladder here will move out, move to the right. Okay, so how fast the top and the T 12 seconds after he start pushing. Okay, 12 seconds after he start pushing. So let's do C. All right, so y squared plus x squared equals to 15 squared. Okay, so how do I get this? You use Pythagoras theorem. So we want to find the relation between y and x. So y squared plus x squared equals to 15 squared. So we get y squared equals to 225 minus x squared. So therefore y equals to 225 minus x squared to the power of half. Okay, then you do dy dx. All right, so dy dx. So half move to the front. You differentiate, then the bracket will become negative half. All right, then you differentiate inside, you get negative 2x. So you get this negative x over square root of 225 minus x squared. So dy dx. So when x is 10 feet away, right? I think sorry. How fast is the top? Total square. We start pushing. Okay. So when x is 10, why you use x is 10? Because initially it's 10 feet away. So therefore we use this, right? So dy dx, you get negative 2 square root 5 over 5. You use your calculator, right? So when you do dy dt, you want to find dy dt. So we use this dy dt over dy dx times dx dt, right? So you get the answer 0.22.36 feet per second going up. So how fast is the top of the world moving up the world? 12 seconds after we start pushing. Okay. 12 seconds after we start pushing. How fast is the top second? Okay, so here, 12 seconds. Okay, this is something I didn't see 12 seconds here. So if we initially 10 feet away from the wall is being pushed, so it should be here. Okay, but now it's 12 seconds later. Okay, 12 seconds. So 12 seconds is If it's 12 seconds, so we want to find the distance of x after 12 seconds. So 12 seconds will be dx dt. So the rate of change is d over t equals to v. The v is 1 over 4. Therefore, the d is vt. 1 over 4 times 12. So it's 3, right? So it's going in 3, right? 3. Therefore, it's 7, right? So therefore, okay, so if 10 meters, we have this, right? Okay, so when there's 10, so I change this one to dy dx. Now it's dy dx. So now we cannot use this because this is 10 meter away. Now it's 7 meter away. It is 7 meter away from the original, right? So 7 meter, let me check. Okay, what is dy dx again? I forgot already. Dy dx is negative x. All right. Okay, negative x. All right, so this is negative x, so negative 7 over square root 225 minus 7 square. All right, so don't worry. Square root 225 minus 7 square. All right, so we have negative 7 over 7 times square root 11 over 44. All right, therefore dy dt. All right, so dy dt is negative 7 times square root 11, 44 times 1 over 4. All right, so time negative 0.25. So you get 0.1319, right, feet per second when after 12 seconds you start pushing. Okay, so after 12 seconds start pushing, the radar will be here. So it will ask you to find, okay, oops, all right, sorry, how to make it back. Oops, okay, okay, 1, 2, okay, so after 3, that's mean it going here 3, here left 7. So the question asks you what is the rate going up when x equal to 7, right? Because after 12 seconds, it moved 3 meters from the original to here is 3 meters. So therefore, we have 7, x becomes 7 here, right? So therefore, it's 0.113, right? So the exercise, okay, you can do is textbook 2.12, page 67, and 2.13, page 70, and formative exercise 2.4, question 4 and question 5, page 75. Okay, so this is how you solve the rate of change of two quantities. Okay, so depends on the quantity. Sometimes it's volume against height, volume against the length. Okay, or the if sphere is volume against, if cone, spherical balloon, like that is a volume against a radius. Okay, so this is how you solve lah, huh? All right, so anything, please ask. Okay.